Hello, I'm William Burgess, and I'm going to be talking to you today about detecting access token manipulation. So a little bit about me. So I'm a security researcher at Elastic. I used to be part of Endgame before it was acquired. And I used to be a pen tester at a UK consultancy, MWR, where I primarily did red teaming, purple teaming style assessments. And my research interested generally everything and anything to do with sort of low-level Windows internals. My objectives for today are threefold. Firstly, I want to help defense practitioners understand how access tokens work in Windows environments. And access tokens are intimately related to a number of other sort of key concepts in Windows security. And in my opinion, if you ignore those relationships, then you only get a surface level understanding. So my definition of access tokens and access token manipulation is perhaps far broader than you might be expecting or perhaps used to. The second objective is to show how attackers abuse legitimate Windows functionality to basically compromise entire domains. And in my experience, this is often as simple as finding some credentials and then abusing existing Windows trust relationships. And then lastly, by showing the art of the possible in both offense and defense, I hopefully help defense practitioners understand their own ability to detect and respond to these type of attacks, understand how their technology such as EDRs can detect this type of behavior, and then use this as a springboard for future threat hunting. My agenda today is threefold. So firstly, just going to cover some Windows security internals. So this is going to focus on logon sessions and access tokens, and then a brief recap of network authentication. The second part is going to cover three kind of techniques about how attackers can abuse access tokens. This is going to focus on the net-only flag, pass the ticket attacks, and overpass the hash. And then the last part is going to be how we can start to detect these types of attacks. Now, my research when I started out was essentially looking to develop userland hooks for these types of attacks. So my focus really was on hooking, and the proof of concepts I'm going to show will be predominantly hook based, but I will show other sort of native sources of telemetry along the way. So the first part I'm going to cover is some Windows security internals. And one of the key things to understand is the relationship between logon sessions and access tokens. And the best way to demonstrate this is to show what actually happens when you log on. So in this example, we have the user Cosmo who's logging on. And when they enter their password, basically the local security authority or the LSA in a domain environment will typically forward this to the domain controller, who will then actually authenticate the user. Following successful authentication, the LSA produces two key artifacts, so a logon session and an access token. And the key thing is that a logon session is what it says it is. It indicates the presence of a user on a machine. So it starts when they're successfully authenticated and then ends when they log off. And there are two really key points about this relationship that I just want to highlight. So firstly, access tokens are always linked to an originating logon session, and you can see that via the auth ID parameter here. And so a logon session can have thousands, hundreds of access tokens associated with it, but access tokens only ever can be associated with one originating logon session. And so secondly, access tokens act as a proxy or an extension of the logon session. So you as a developer, you only ever interact with access tokens, you never touch logon sessions. And as a result, access tokens act as a volatile repository for the security sessions associated with that logon session, and hence they determine the security context of the user. And by security context, I just mean the information cached in the token, so group memberships, privileges, etc. So if we continue with that example, once the LSA has a token, it will typically spawn the user's shell, which is normally Explorer, and it will attach this token to it. And so every process has to have a token attached to it, and this is typically referred to as the primary access token. And then subsequently, any other processes spawned by the shell they inherit the security context of the parent, and then they get their own local copy of this token. And the key thing here is that the token, again, acts as this volatile repository, so a process can change its own settings without affecting other processes. And so Chrome, for example, can create a restricted access token to effectively sandbox itself from memory corruption style exploits, so that if an attacker is successful, then the damage is restricted. And it can do this by removing dangerous groups or privileges, etc. And the reason why this is so important is that the access tokens are the fundamental component of Windows security. So whenever a process or a thread attempts to access some secureable object managed by the kernel, whether it's a file, process, or thread, Windows will do an access check, and it needs three things to do this. It needs the authorization attributes in the token, which in this case will be a restricted access token. It needs the intentions up front, because in Windows, the access check for performance is only done the first time, and you need to state exactly what you plan to do with the object. And the third thing is a security descriptor. So this is contained within the object, and it basically has a access control list that says who is not able to access it. And then based on these, Windows will make a decision. And this is why the ability to control the security settings in access tokens is so important. So the next thing I'm just going to briefly cover is network authentication. So this is a kind of classic scenario in a domain where you as a user, you want to access some resources across the domain, say a file share or something. And so in this, I'm just viewing the network shares of the domain controller. But how does this actually work under the hood? And now the key thing here is that the access token and the logon session are unique to the client machine on the left. And so the client can't send its token over the wire or something like that, because the server still can't verify who, just because you say you're that user, it doesn't know, and it doesn't correspond to a meaningful logon session, so it's basically worthless. So effectively, you need to re-authenticate to the server. Now for interactive logons, and in fact, every type of logon apart from network, Windows will automatically cache your credentials. Now it doesn't matter if it's a Kerberos ticket, an NTLM hash. When you try and access a resource, Windows will automatically try and authenticate on your behalf for you. And this is the intended design of Windows single sign-on, and is also the reason for lots of, say, NTLM relay style attacks. From the server perspective, it's again produced with two key artifacts. It gets a logon session and a token. There's a few key differences here, though. Note that this is a network logon session, which means it represents a remote client. And secondly, that there are no credentials backed up by this. And this is typically what's known as the double hop problem. So you can't auth off that box to someone else because there's no credentials there. Now, I mentioned before that every processor has a primary access token. And so when the server is presented this token, well, what does it do with it? And this leads nicely to the Windows concept of impersonation. And so typically in, say, a multi-threaded application, multiple threads may try and adjust that volatile repository of security settings at the same time, which could lead to sort of weird bugs and race conditions. And to solve this, Windows has a feature called impersonation, which basically allows a thread its own local copy of an access token, which it can then modify as it sees fit. And this is known as impersonation. And the key thing here is this is an impersonation token. It's applied to a thread. And so it allows the thread to slip into a different security context. And this is exactly what the server does. So in recap then, we have the user re-authenticated over the network. They have a new network logon session produced, and the server is given an impersonation token, which links back to that originating network logon. The server then uses this token to perform work on behalf of the client. And so all access checks, they'll use that thread's token, which is that remote user. And this is how Windows can force access control in client-server applications. And as a note, just for most of Windows sort of key communication protocols, this is handled automatically. The server just calls the API, RPC, impersonate client, and it automatically starts slipping into that security context of that remote user. So the second part of this presentation is going to start to focus on how attackers can actually start to abuse access tokens. Now, I want you to consider the following scenario, which is very typical, which is an attacker's phished a user and they've got a shell or a foothold in a corporate network. a key thing here is it doesn't matter what payload the attacker used or whatever, they're running in a process which is in the security context of that user. And in this case, that user has no privileges across the domain. So any attempts will use their cache credentials and will fail. So the attacker's got to move quickly, but what can they do? And so they effectively have three options here. And the first one is they can steal the token of an already logged on privileged user. And again, because they want to move laterally, they need creds cached, so a non-network logon. And this, they can then, with this token, they can then impersonate or spawn a process or whatever, but they can then move laterally using those cached credentials. If they can't find credentials, sorry, if a user already isn't logged in, then they need to find credentials. And if they do, well, then they can create a new logon session with these stolen credentials and then impersonate the return token or spawn a process with it. And then their last option is, again, they still need stolen credentials, but they can just change the cache credentials associated with their current logged on user to these stolen credentials. And so this could be legitimately through an API or illegitimately, say, by directly modifying LSASS memory. And the examples we're going to cover are largely focused on 2 and 3. And so the first case is sort of legitimately used via this net-only flag. And the subtitle here is from a really excellent blog by Raphael Mudge. And so say an attacker, if they find creds, well, they can use the logon user API to basically create a new logon session and get a token in return. And so they can supply a username, domain, password, and a logon type. And the logon type basically is what you specify for the logon type depends what kind of token you get back. In this case, we want creds associated with it, so we're going to say an interactive logon. In the case of an interactive logon, we get a primary token back. So if we want to impersonate that on a thread, then we need to convert it to an impersonation token. And so we can use duplicate token X to do this, and we just apply a token type of token impersonate. And then lastly, having got an impersonation token, we can use set thread token or impersonate logged on user. And this will make the thread slip into that security context of that logged on user. And note that both of these are wrappers around NT set information thread, which will be important later. Now, say an attacker finds valid credentials, they try and log the user in, but access is denied. And this could be a legitimate reason, the account is valid, but that user can't log on to that particular machine. Well, what can they do? Now, things get very interesting if you supply this log on new credentials flag. And what this does is it clones your current access token, but it changes the credentials cached with it. And so when you try and then access a network resource, it will authenticate with the stolen credentials. And so you'll get a session on a remote host as the user who belongs to those stolen credentials. And you can do the same thing with create process with logon W. It's got a logon flag of net credentials only. These flags are equivalent. All they mean is that these credentials are only to be used on the network. And this is basically what the run as tool, the native Windows tool run as does with the net only flag. It allows you to specify credentials only to be used in the network. And so I have a quick demo. And so we can see here that I am running as the user Cosmo. And then I'm just going to try and enumerate the $C or the admin share on the domain controller, and I'm rightly denied because I'm just a standard user. There's no reason why I should be able to do this. This is contrived, but I've just got on the domain controller here now, I'm just dumping creds and I can find the clear text domain admin password. I then can use run as with that magic net only flag and use those credentials to spawn a new process. And remember, this clones the current access token but changes the cache credentials. Just to note that this creates a new logon session. So we can see it there, the 4917E0, and then we can use the sysinternals tools to enumerate them. So we can see this new credentials logon type. And similarly, you also get an event 4624 in the Windows event log, again, logon type 9, and you can see the target outbound username. Now, if I just spawn a new command prompt, again, I'm going to run who am I, and this will just show I'm the same user. Also note that the credentials are not validated when you enter them. They're only validated when you try and remotely authenticate to a host. And so now I'm going to enumerate the $C share and I'm an admin. And I can similarly just enter a new PS session just to confirm the same thing. If I run who am I here, I'm the administrator. And you can apply very similar behavior with Kerberos, and this is typically known as pass the ticket attacks, and this is the second attack we're going to look at. As a brief recap of Kerberos, so when you enter your password, what the Kerberos provider will do is it will hash it will take the NTLM hash of your password and it'll encrypt a timestamp and send it to the domain controller. The domain controller, once it verifies your identity, will send you back a ticket granting ticket or a TGT. Then whenever you want to access another resource across the domain, you give this to the domain controller and say, I want to access this file share, and it will give you a ticket granting service ticket, which you can then provide to that file server and you can start accessing stuff. And what Pass the Ticket does is it allows you to just basically arbitrarily change the credentials associated with your logon session. So you can just apply a TGT for a domain admin, and then you can access the domain as that user. The magic is mainly done by this LSA call authentication package function, which basically makes an RPC call to the Kerberos provider. And you basically pass a massive buffer of data of the protocol message you want to send to the Kerberos provider, and you just pass a pointer to this buffer. In the case of a pass the ticket attack, it's a Kerb submit ticket message, and so effectively you have this structure in memory followed by a massive blob of a ASN encoded Kerberos ticket that you want to apply to your session. And so I have a quick demo of this as well that I can show. So once again, I'm the user Cosmo, and I'm medium integrity, so I'm not elevated when I'm performing this attack. Likewise, I have an existing TGT for the user Cosmo. Once again, I can try and access the admin share of the domain controller, and I will rightly be rejected. Access denied. I can then again switch to the domain controller, and I'm going to export all the Kerberos tickets I can find in memory, and then I'm going to copy over a TGT for that admin user. I can then use the Kerberos PTT command to pass the ticket, and it will load this up from disk and basically submit that as part of that buffer to the function. And now we can see that I do have a TGT for the administrator user in my Kerberos cache. So if I try once again to access that $C share, I can access it now because I have that domain admin ticket. A couple of things to note. So as I showed there, we were medium integrity, so you don't need privileges to change your TGT associated with your session, but obtaining a TGT in the first place is a different matter. You don't need to create additional logon sessions, but bear in mind when you apply a new TGT or blitz the old one, the way to get around this is that net-only gadget that we saw before. So you create a dummy new credentials session, and then you can apply the TGT to that session while preserving your own. Also note that through this API, you can do a lot more than just pass the ticket. You can basically dump credentials as in a high integrity context. And the key thing here is that this doesn't involve opening a handle to LSASS, which is what a lot of cred theft is traditionally based on. And so be aware that this is quite a big gap actually in any credential theft logic based on that kind of traditional access to LSASS. So say sysmon process access. And the last example I'm just going to run through pretty quickly is over pass the hash. So for typical pass the hash attacks, what happens is you'll get a tool like Mimikatz, which will basically parse LSASS memory, it will enumerate the logon sessions, and basically it will find the NTLM cache credentials, and it will basically just directly overwrite them in memory. Screen's gone off. Oh, no, it's back. Sorry, ignore that. And then when you try to then access a network resource, it will just supply these overwritten credentials. And so again, you'll get a logon session as the stolen credentials. The screen's flickering. oops, sorry, 1 second. So for overpass the hash, effectively what you're doing is you're translating an NTLM hash for a user into a fully fledged TGT for that user. And so you're doing a similar thing, but this time you're sort of injecting it into the Kerberos provider. So you enumerate the logon sessions, you find the appropriate place, and you patch in that new hash. But the key thing this is sitting in memory. But then once you try and actually access some remote resource, it will kick off the normal Kerberos authentication protocol. So you'll basically, don't go too much into detail into this, but you'll get a TGT for that user whose credentials you have access to, and then you can access the domain as that user. A couple of notes about sort of quirks of how, say, Mimikatz does this. So again, firstly, it creates this kind of sacrificial net-only process, and this is to preserve your TGT, as I mentioned, but this does generate a new logon session. It will then acquire debug privilege or impersonate a system token, but in order to be able to get a right handle to LSASS. And then, as I said, it will parse LSASS memory, find the appropriate logon session, and then just patch in that new hash. And then once again, the normal Kerberos authentication process kicks off, and you have a TGT for that user. I don't have a demo for this for time, but I'll be showing one shortly from a defensive perspective. So the final part of this presentation is going to look at how we can start to detect these techniques. And as I mentioned at the start of my presentation, my research focus was really developing userland hooks. So a lot of the proof of concepts I'm going to show shortly use Frida, which is the binary instrumentation framework, essentially. But I will show native Windows telemetry where appropriate. And the really awesome thing about Frida is it allows us to write sort of custom and scriptable detection logic on the fly. So we can, because it's a hooking framework, we can analyze arguments pre and post function call and make decisions based on, parameters passed to functions or what's returned to a function. And so this can be very powerful for prototyping effectively detection logic very quickly. This is an example of a very basic Frida JavaScript template. We use find export by name to resolve the function of interest, and this returns a Frida native pointer. And then we use the interceptor attach to start hooking. And the on enter and on leave callback functions, this is where the main guts of our sort of detection logic will reside. And here we can start looking at arguments and implementing our logic. And so I started showing this kind of net-only technique. And the two key signals for this was create process with logon with that effectively the net-only flag, and effectively the make token gadget, which allowed you to craft arbitrary tokens, which was a combination of logon user with a net-only flag, and then you impersonate the return token. So I've got a few demos with Frida, just showing these now. So this is an exact run through of the previous attack, but I can show my Frida hook here. We can see I'm resolving create process logon by export by name and then using interceptor attach to start hooking it. And so now I'm attaching Frida to command.exe, and I can run through the same steps. So I use run as with that net only flag and then supply the administrator's credentials. Once again, because it's cloned my access token, I'm the same user locally for any access checks, but remotely it will supply the new cache credentials, and I'm a domain admin on the network. So if we look at my Frida hook now, we can see it spawned a new process, and we can see that process is called create process with logon W. And critically, we can pull out the username, password, etc., but we can see that it's submitted logon flags of net credentials only, which is potentially a suspicious event that we want to alert on. And in this case, just as for this proof of concept, I've added an entry to the event log saying we've seen a suspicious net-only logon session. For the second example, we're looking for that make token gadget. And so here I've used a Covenant, which is an open source C2 framework. I've used a PowerShell stager, and we've got a shell basically. And so I'm going to attach my Frida script to this PowerShell process. Now, if I switch to my attacker machine, I'm going to run the make token task, and this will do exactly as I said. It will log on a user with the logon type of new credentials, so that's suspicious net only flag, and then start impersonating that user. So we can run that task, and we can see that it successfully impersonated it. So in terms of a Frida hook, well, how do we detect this? Well, again, we want to monitor for someone logging on a user and then subsequently using that token in a call to, say, impersonate logged on user. So in this case, I've actually hooked log on user XXW, which is what log on user A and W both end up calling. And we can see that, again, new credentials that new credentials flag has been passed. And then if we track that return token, we can see that that was then passed to this impersonate logged on user call, which is suspicious. That's the kind of behavior we want to alert on. So once again, we can emit an event, and I've just written a new entry to the event log showing that this potential make token behavior has been detected. In terms of other telemetry sources, so for those net-only logons, we can use the Windows event logs, and then for any process spawning signal, we can use process events. Note, impersonation, as far as I can see, has no native real way to track and is also exceptionally noisy unless you're looking for targeted things. I showed this before, so event logs 4624 logons. You want logon type 9, and then the logon process name is seclog, so it's the secondary logon service. And notice you can see the differing username and then target outbound name. In terms of process data, you might want to look for users, so this is high or medium integrity, spawning processes as the same user but a different auth ID. Hence, it's a new logon session, so it's a net-only gadget. And you might also want to ignore things, common admin tools like run as. Also note that because it goes through the secondary logon service, I don't think you can spoof the PID, as far as I know, for create process with logon. I haven't had too much time to go on this today, but you could also take this a bit further and look for processes spawning processes as other users, full stop. And again, look for high and medium integrity user processes. And this caters for that case of someone stealing a token and then spawning a new process with it. And then again, you might want to ignore standard admin tools in doing this. So the second technique we looked at was pass the ticket, and the real indicator here was that LSA call authentication package with the curb submit ticket requests. And so I've got a demo for this as well. So once again, we can see I'm Cosmo. I've got a TGT for Cosmo. I also actually have a few TGSs when I was accessing file shares, and I can try and access the domain controller, and I'm rightly denied again. I'm then going to attach Frida to Mimikatz, and then I'm going to apply the same ticket as before via the PTT command. And now what we can see is in my Frida hook, so I've hooked LSA call authentication package, and we can monitor for the type of message that we want to find, which is in this case a curb submit ticket request. That data buffer there is that big buffer I mentioned that's passed to the function call, and then I can use the imp packet Python libraries to parse that Kerberos ticket out of memory and see what ticket's being applied. And in this case, the user is applying a ticket to a different user not logged on, and this is evidently pretty suspicious. So again, we can say potential pass the ticket, attack detected, and we can add something to the event log. As so. I'll just skip this along a bit. As a quick example as well, I don't go too much into how the guts of this works, but just confirming that I could access it. I'm now going to purge the cache, and then I'm going to actually use the Mimikatz LSA dump inject command. I'm going to get the KRBGT hash to basically make a golden ticket. I'm not going to go too much into how this works, but it's the RID 502 account, and we can put out that NTLM hash. And likewise here, we can use this, the golden ticket command, and then we can see it. If I check now, once again, we can see LSA call authentication package has been called, and we can pick up this ticket. And so this is fake user at astro.testlab, as you can specify any user for a golden ticket for a temporary period. And this is obviously very suspicious as well, so we can write an event log as well. And so the key thing here is it doesn't really matter what Kerberos attack you use. At the end of the day, you have to submit that ticket, whether it's on disk or in memory, via that function to apply it to your logon session. In terms of native telemetry sources, I looked at the Kerberos ETW providers and I couldn't really find anything that seemed to capture what I want, which was quite disappointing. There's better logging on DCs, but this can be noisy and obviously isn't the client side of it. For the last example, I'd overpass the hash. Again, this had that create process of logon, net only gadget. We also had debug privilege and impersonate system token. Debug privilege is very noisy in my opinion, so I've ignored that, and we're going to focus on impersonating a system token, which is a definitive escalation of privilege, right? You're going from high to system. Likewise, you can look for right-handed access, but this is kind of a traditional known technique, and this wasn't really the focus of my research. So I just have a final quick example of overpass the hash. And so in this scenario, we're simulating a credential shuffle. So I'm actually interactively logging on the administrator user, basically. So they have cached credentials in memory that I can steal. Also note when you use run as, sometimes for RID 500, it automatically elevates. So the process is already high integrity. So once again, I can attach Frida to Mimikatz. I can elevate, and then I can dump credentials. So I can see the plain text credentials, but for overpass the hash, I'm interested in that NTLM hash. So I can use that in Mimikatz to spawn a new command prompt, which I can then move laterally with. Again, because I'm net only, I'm the same user locally. Again, note the credentials are not validated until you try and authenticate remotely, and then I'm a domain admin. If I switch to Frida, I've actually got a new hook. So basically I've hooked NT set information thread, which I said is a wrapper for those impersonation functions. When it's being used to impersonate a token, I query that handle to the token in flight and basically look what user it is. And if it's a system token, then this is a suspicious event and we might want to emit an event on it. And the second example here is just that create process logon with those net credentials. So two of these are potentially very suspicious behaviors that we want to look for. In terms of telemetry, again, as I said, for net only stuff, Windows event logs, process events, and then I didn't cover this, but right handle to access to LSAS, you can look for sysmon event ID 10, so process access. As a note, before I wrap up, I just want to highlight two things. So from my research, a lot of these signals here are highly anomalous. Like these are pretty rare, especially again, if you look for high, medium user activity, these are rare, and I think quite high fidelity signals of bad behavior. Again, if you rule out admin tools as well. The second thing is, because apart from impersonation, all of these calls are making RPC calls to either the secondary logon service or the LSA Kerberos provider. And so a typical weakness of hooks is you can just make a direct syscall. In this case, you can't do that because it's not as simple, right? If you've ever looked at making RPC calls, they're quite complicated. And so some of the traditional weaknesses of hooks are slightly mitigated by this. It's not impossible, but it increases the barrier of an attacker being able to or wanting to spend time doing that. And I shall wrap up there. So hopefully I've shown that Windows security can be intimidating. Things like Kerberos NTLM can be complicated, but I hope I've shown at a high level, conceptually it's simple. Think of access tokens, logon sessions, and cache creds. This is the framework from which it works and which you can start compromising domains from essentially. And hopefully I've shown that because of these constraints, irrespective of what tools you use, what authentication provider you're abusing, basically attackers are always under the same set of constraints. They always use these net-only gadgets to create these sacrificial logon sessions, etc. And so you'll see the same signals for irrespective of the kinds of attacks, even unknown attacks you don't know yet. And hopefully these techniques aren't necessarily supposed to be sort of prod ready, but they show the art of the possible from both an offensive and defensive perspective. So hopefully, as a defense practitioner, you can see kind of what an attacker can do, and you can assess your own ability to detect and respond, and the tech you use, the EDR use, you can see whether they can see this kind of stuff. And it gives you a springboard for future threat hunting as well. And I shall wrap up there. Thank you very much. Hello, can you hear me? Perfect. Thanks everyone for attending my session today. I saw one really good question from Michael that was essentially about how do you operationalize the hook-based detection, and then do you recommend deploying Frida in production? I think loosely there's kind of two concerns with any detection logic, which I suppose from a sort of an EDR perspective is a noise, so how many false positives do you get, and then the actual performance implications of it. In terms of these specific hooks, like testing, getting an idea or feel for the actual activity and how rare it is the number one thing for me, at least, to feel whether it's even worth even operationalizing it down the line anyway. Hooks in particular can be, some APIs can be very noisy, they can be quite performance intensive, so you have to be careful with what exactly you're hooking. So I think as well, trying to get rid of as many kind of superfluous API calls or events as soon as possible is also a really good way of honing in on that exact behavior you're looking for. I think in this case, these behaviors I've highlighted just happen. They do seem to be really rare in my experience. If you look for in your kind of enterprise, if you look for business users creating these net log-on sessions and submitting new TGTs to their session, this stuff is rare, so it's a really good basis for detection at a starting point. And yeah, you'll get a few false positives, but at least it's high fidelity enough for us to be able to make it valuable detection logic. In terms of operationalizing Frida, I mean, pending any license agreements, like Frida is amazing. It's really powerful, and you may, but it's obviously running Python under the hood, so that may have performance implications that you would want to worry about. I'm just, sorry, I apologize, I'm going to switch between two screens. I'm just looking at the discussion now to find another question. Would it be possible to use ETW providers to enrich the data set and detect all the techniques, especially the one not currently detected with Standard? You could do that. I admit, as I said before, my research was mainly focused on, as I said, developing userland hooks. ETW is an incredibly valuable resource for a lot of kind of key Windows events. So you could, again, providing you have the infrastructure in place to do this, you could enrich the data set with some of these things. As I mentioned, I was a bit disappointed with ETW for some of the Kerberos stuff, because from either an RPC perspective, calling into the LSA, or the actual Kerberos ETW provider, I couldn't really find what I was looking for. There is better logging on domain controllers, but the purpose of this was to find client-side manipulation style attacks. So for some things, there is a bit of a gap, I think, from the standard Microsoft, and even say things like sysmonset. I mean, as I highlighted, if you're an attacker, if you just use LSA call authentication package and do all your CRED kind of manipulation through Kerberos, anyone looking for someone grabbing a handle to LSAS or something, you're not going to see any of that activity. So there are some limitations on what you can natively detect. I shall have a quick look for any more. I'll wait a little bit if anyone has anything else. Otherwise, I can wrap up the session. I guess, yeah, nothing else. So I guess I'll leave it there. Yeah, thank you very much for attending.